Okay, so this section is on direct variation. Our LEQ for today is how do we identify direct variation and use direct variation to solve problems. So the first thing I want to start off here is a key concept. And it says a direct variation is a relationship in which the ratio of y to x is a constant k. So we can say y varies with x. So in simples, what that means is y over x is equal to k. So basically your slope, okay? So like we were saying, your slope, your y over your x, we're gonna say that that is equal to k, or we can say y is equal to k times x, where k cannot be 0. So if k is 0, there is not a direct variation. So for example here, if we have y is equal to 2x, my k is going to be equal to 2. So again, here is a graph of y is equal to 2x, and my direct variation there would be 2. So we're going to go ahead and start off with example number 1. So example number 1 says the graph shows the cost of different amounts of trail mix. We're going to determine if the relationship between the cost and the weight of the trail mix is a direct variation. So to determine if it is a direct variation, what we are going to do is we're going to find the cost, so the cost y over the weight, which is our x, so y over x. So we're going to start here, and there's 3 points that are already on this graph for us. So we're going to go ahead and start there. So the cost, so the first one says $14 for 4 pounds. Okay? The second one, which comes out, so if we were doing the unit rate here, would come out to $3.50 per pound. Okay? The second one is $28 per 8 pounds. And if I figure that out, $3.50 per pound. And the third one here, I have 42 for 12 pounds. So $42 over 12 pounds is going to be $3.50 per pound as well. So I can look at that and say, okay, well, the ratio of $3.50 per pound is a constant rate. So since the graph passes through the origin and the ratios are constant, that means that the cost of trail mix varies directly with the weight of the trail mix. Okay? So basically, you want to write that down in your notes. So I'm going to say it again. I'm not going to write it here on the board just because I ran out of room here at the bottom and it's going to be all squished and hard for you to read. So I'm going to read it one more time for you. Make sure that you have this written down in your notes. I'm going to be checking it. So again, you want to say the ratio, $3.50 per pound, is a constant rate. Since the graph passes through the origin, we can say, since the graph passes through the origin and the ratios are constant, that means that the trail mix varies directly with the weight of the trail mix. Okay, so the cost of the trail mix varies directly with the weight because our ratios are equal, so it's a constant rate of change, and also it passes through the origin. Okay, and that should kind of remind you of graphing proportional relationships when we did that. It's almost the same thing, but we're calling it direct variation at this point and kind of taking it a step further to get into those algebra terms. So example number 2 says the equation 40x represents the distance y in miles an ostrich can travel in x hours. I need to determine whether there is a constant variation, and if so, explain what it represents in this situation. So what I'm going to do is I'm going to use my y is equal to my y is equal to kx. So y is equal to kx. And I'm going to say y is equal to 40x. So if I look there, the K and the 40 line up with each other. Okay, and since that happens, I can rewrite this using my key concept. So I can rewrite this as y over x is equal to 40, because that's what my key concept says. And if I want to get the 40 by itself, because I want to solve for the k, I can divide each side by x. And when I do that, I get y over x is equal to 40. So basically, I need to explain what if it's a constant variation. Well, it is, right? Because I just showed that. And then I need to explain what it represents in the situation. So when I'm looking at this, I can say that my constant of variation, so constant of variation is 40. And at this point, what it represents, it means that the ostrich, so this means the ostrich can travel 40 miles per hour. Okay, so the distance, so remember the y on the top is the distance and the time is on the bottom. So this means that the ostrich can travel 40 miles per hour. All right, example number 3. It says the time it takes to burn amounts of information on a CD varies directly with the amount of information. So it already tells me it varies, okay? So I'm not trying to figure out if it does or if it doesn't. It already tells me that. It says write and solve an equation to find how long it will take to fill a 700 megabyte CD. So step 1, we're going to use the equation y is equal to, we're going to change this to a k. So y is equal to kx. So y is equal to kx, and we're going to choose any point on the graph, and then we're going to solve for that k. So again, y is equal to kx. I pick any point on here. I'm going to just pick this lowest point right here. So right there, 2.5 comma 10. So where y is, I'm going to plug in 10. Where x is, I'm going to plug in 2.5. I go ahead and do that. I solve for k, so I divide each side by 2.5. I end up with k is equal to 4. So now I know that my constant, I knew that it varies directly, okay? But I needed to find my constant of variation. So that's what I did in step 1. Step 2, we're going to use what we found. So we're going to use that k that we found, and we're going to write an equation. So we're going to say that y is equal to k times x, and wherever k is, I'm going to replace it with 4. So y is equal to 4x. All right? So here I have my equation now. So the first thing I did was I found my constant of variation. Then I wrote my equation. Step 3 says find how long it will take to fill a CD. So I'm going to take y is equal to 4x, and where the x is, the x says the amount of information or megabytes, and it's asking me how long it would take to fill a 700 megabyte CD. So my x is going to be 700, so 4 times 700, so y is equal to 2800. So it's going to say it will take 2,800 seconds to fill a CD. So that was example number 3. And I have one last one here to go over, example number 4. It says the equation y is equal to 1.5x represents the relationship between the number of heartbeats y and time in seconds x for a dog. The graph shows the heartbeats for a cat. Which animal has a faster heart rate? Explain. Okay? So I'm given an equation for dogs, and I'm given a graph for cats. So the first thing you need to do is you're going to look at the equation. So in the equation, y is equal to 1.5x. The slope or the unit rate here is going to be 1.5 beats per second. Okay? So that is my constant of change, the 1.5 beats per second. in the graph, the point 1, 2 represents the unit rate. Okay, so here, this point right here represents the unit rate. Again, if I was figuring that out, I would do y over x. So when I do my y over x, I would put 2 over 1, which is the same as just 2. So which is 2 beats per second. So since 2 is greater than 1.5, that means that the cat has the faster heart rate. So if you're given an equation and you're given a graph and you're saying, compare these, tell me which one has a faster heart rate or which one has is faster miles per second, miles per hour, whatever it is, that's something that you can do to compare that. That's it for this section on direct variation. If you have any questions, please make sure that you come into class with them so that I can help you. If not, guys, have a fantastic day.